Alright. We're going to be doing something called ray diagrams for lenses. There are three things we're going to be drawing on each. Does everybody remember what the center of curvature and the focal point are and mean?
No.
Okay.
Oh, kind of.
No.
So center of curvature, if we drew a big giant circle with a curved mirror, that would be the center of the circle. That makes sense to everybody? The focal point's halfway between the center of curvature and the mirror. The focal point is also where anybody remember what this line right here is called?
Normal line.
Normal line, it's also called the principal axis. If a ray of light goes parallel to the principal axis, it gets reflected back to the focal point. Does that make sense? So we're going to be figuring out today is where images form with these kind of mirrors. So we're going to do that by drawing stuff.
So we need a rule.
You need some sort of straight edge. Actually, Michael, do you want to pass out some meter sticks for me?
Please, Michael. Please, Michael. Thanks. Hey, bro.
I know meter sticks are not the ideal thing, so if you have a ruler somewhere, it'd probably be more useful.
Get your shit.
You can use a sheet of paper though. The lines don't actually have to be perfectly straight. They're really just kind of like estimates. Alright, you can use your planners as well.
I just need a rod.
Okay. So there are three lines you can draw for all of these.
What is that? Are you done drawing?
Okay. There are three lines you can draw for all these. The first goes parallel to the principal axis back to the focal point. The second one goes through the focal point back parallel to the principal axis. Third one goes through the center of curvature and back through the center of curvature. We're only going to use two of those at any given time just because it's silly to do all of them. No using the meter sticks as swords.
Why do you have to look at me?
Use your using.
Like,
That's a good purpose.
don't trash them.
Michael, you'd be great fast pick rapper.
Okay.
Is that a racist comment?
Thanks, Kira.
Okay. Alright guys. First ray goes parallel to the principal axis and then bounces back through the focal point. So if you want to color code things, you can make these two a different color. Make your life easier, but not really all that much easier, so don't worry about it too much. Okay, so you see how this is the incoming ray, this is the reflected ray. So if nothing else, draw some arrows to indicate one's going in, one's bouncing off. Alright, the second one is kind of the opposite. It goes through the focal point and then gets reflected back parallel. So we go the top of the arrow through the focal point, and then it gets reflected back. It's clearly ghosts.
Which one is the same?
Okay, so you can make the two that are coming in one color and the two that are going off the mirror one color. Does that make sense? I only have black markers, so I can't really color code up here. But alright, the image forms where the two reflected rays intersect. So where this one and this one intersect. So the top of the image forms right here. So that's where we draw the top of the arrow. You see how it's below this principal axis? That means it's going to be upside down. So you're going to draw it starting there and there. So the bottom of the arrows that we're drawing always start at the principal axis, and the tops always go to where the rays meet. Does that make sense? Okay. So if it's in front of the mirror, does anybody know what kind of image that's going to be, real or virtual?
Virtual.
Real.
Real.
Image forms in front of the mirror, it has to be projected onto a screen, and it's real. It forms behind the mirror, it's virtual. So is this image real or virtual?
Real.
Real. Is it upright or inverted?
Inverted.
Inverted because it's upside down.
Oh.
Alright. And is the image larger or smaller?
Same size. Smaller.
Smaller. You can see from our diagram here. Okay, so if you have a curved mirror and the object is outside the center of curvature, it always appears like this. So it's always inverted, smaller, and real if the object is further away from the mirror than the center of curvature.
Which part is smaller?
Smaller is, see this, that big and that big. So if the actual line, like the actual arrow is smaller than the object arrow.
Oh, okay, that's the word.
This is much more wish the one outside.
No, mind.
What is that?
No mind.
Okay. Everybody understand why it's smaller?
Yes.
Because the one you drew is smaller than the original. Anybody have any questions? So these three things are always true no matter what the mirror, if it is further away than the center of curvature. Does that make sense to everybody? Okay. Can I erase this?
Yes.
Do the next one here. Alright, number 2. This time we are at the center of curvature. So we do the same kind of thing. First line we draw parallel to the principal axis. And then back to the focal point. And what's the next one we draw? Opposite, so through the focal point and back, parallel.
Yeah, Brian. Yeah, it's Brian. Black.
Alright, I did not draw this one right, so as you guys are doing this should be the same spot as the center of curvature if I drew it perfectly. Does that make sense?
Why?
Did it matter on the last one?
It didn't matter as much in the last one. This one has like a specific spot it has to be. So it should be at C.
Same size?
What?
Should it be the same size?
Should be the same size and at C. It's hard to do, so like I'm not gonna like actually grade you on like whether you drew your lines perfectly and got it at the same place, but you do need to know what it should be. Does that make sense?
So the right should be at C.
Should be at C would be a good thing to write. And should be same size. Alright. What is this real or virtual? Real. Is it upright or inverted? And like I said, it should be same size. You guys kind of understand how to draw these? Alright, can I erase this one?
How do you know whether it should be same size or bigger?
The only time it should be the same size is if it's at C.
Okay.
So whenever it's at C, it's going to be the same
Other
size.
than
If
that,
you draw it and it's
Yeah.
not at C, how do you,
If this starts at C,
then
it should be, the image should be at C in the same size.
And then other than that, it'll be smaller.
Other than that, you'll be able to tell from like the diagram doesn't have to be perfect then. Does that make sense? And there are equations that we're going to do with these two, so you can actually figure out what this is supposed to be mathematically as well. Alright, number 3. This time we're between C and F. Same deal again.
Everyone is.
They drop something.
Oh, they're above us.
So now again.
Jesus. Always assuming the worst at this school.
Yeah, that's awesome.
No one jumped out the window.
I can't.
Or sticks.
That just
Okay.
sounded like Ava.
So same thing. So we go down to the focal point. And again, where the reflected ones intersect is where our image forms. So it's going to be right here. So we always start at the bottom of the arrow at the line and go down. Since we're going down, it's going to be inverted. What about this one? Is this real or vertical? Real.
Real inverted bigger.
Can we slow down a tad?
Just you can sit on 10.
Just when I'm switching colors.
Everybody understand why it's real? It's real because it's in front of the mirror. So that the two reflected rays intersect in front of the mirror. So that means it's real.
How could you tell if they, yeah.
What?
Where is the mirror? I thought the mirror was the curve.
That's the mirror.
Well, then haven't they all been in front of the mirror?
They've all been in front of the mirror.
How can you tell if it's behind it? It'll be.
We'll see.
Well,
Number 5.
number 5 is where it ends up behind the mirror.
Then what about inverted?
Actually, number 6.
Inverted means if it was right side up, it would be like
The arrow would just be upright.
your arrow would be upright. It would be the same direction.
Okay.
And then size, you're just comparing. So anytime it's between these two, these things are going to be true. Real, inverted, and bigger. Alright. So again, the real has to be projected onto a screen. Are all you people who are color coding okay?
Yeah.
So they come.
You good, Sarah?
Do we have color?
You don't have to color.
Is that like?
It would have been right on that. Real inverted.
Inverted, bigger.
What is color?
Okay. This time, we go down a little further. It's at the focal point. So when it's at one of these two things, something specific happens both times. This one's a little easier to draw though. We draw parallel and back through the focal point. Alright. Does anybody remember the other line we can draw? Can we draw one through the focal point and back parallel?
Sure.
No, so it's going to be going straight down. The other line we can always draw, the way I've been drawing, is like it's coming from the center of curvature and back through the center of curvature. Or through the center of curvature and back. So if we line up the center of curvature and the tip of the arrow, it goes like this. Most annoying sound ever. Alright, so there, and then it goes back through the center of curvature.
So we don't have to draw that line.
On this one you do, because we can't draw a second one this time.
Is that supposed to be erased in the middle, or is that part of the line? Like in between the C and the F?
It's part of the line.
Okay,
Part
well
of
it's
the line.
faded, that's what.
It's drawing with a meter stick on the board and a marker. Ideal.
What is it about?
When you have a line coming going through or coming from the center of curvature, it bounces back through the center of curvature.
So there's no image.
There's no image, because these lines ever intersect. No, because they are, if I drew it correctly again, they're parallel. So the answer to this one would just be no image. And that happens with a concave mirror if it's at the focal point. Does that make sense? So, really you never need to draw this line if it's at the focal point. You just know that it's no image.
Real bad.
Right. Can I erase this one, or you guys?
Yes, sir.
Can I erase this? Alright. Almost done with these guys. Alright, number 5.
So do we not?
Now, we're inside the focal point. We can still do what we did before. So this one always works. The parallel. And then back through. Okay. We can't go through the focal point and parallel again because we're going backwards. So we act like it's coming from the focal point. So we start like this, line up the ruler on the focal point and on the arrow, and go from the arrow up to the mirror and back parallel that way. So that's that. Okay. Do these two lines ever intersect on this side of the mirror? No. So we can't have a real image here because they're never going to intersect. Does that make sense to everybody? But they will intersect back here, won't they? I'm actually going to continue this line a little bit here. Alright, so if we go and then we're taking the reflected rays and tracing them back behind the mirror so where they look like they're coming from. Does that make sense what I did there to everybody? So I took the two reflected rays, since they're never going to meet on this side, and traced them back. So they do intersect on the other side this time. So now we draw our arrow right here, and down. Questions on how I got any of this? So what kind of image is this? Virtual. It's behind the mirror. Is it upright or inverted?
Upright.
Upright
Bigger.
and bigger.
Good job,
How did you know it was upright?
Because the arrow is pointing the same direction for both. So this arrow is pointing up, this arrow is pointing up. In the previous ones, the first arrow has been pointing up, the arrow we drew have been pointing down.
Is it virtual, like behind the mirror? Is behind the mirror just kind of like to the right of the mirror?
To the right of the mirror means it's virtual. Behind the mirror. Sean?
How is it bigger?
So this is our original one, and this is the one we found the image of. So you see how this arrow is just bigger than that one?
Ah.
So that's all we do to find bigger or smaller, is just compare the two sizes. Alright. Any other questions on this one? Okay. So those are pretty much all the examples of concave mirrors. So this is a concave mirror with reflective stuff on the inside, like inside of the cave, remember? Convex mirror, there's only one thing that can happen. So this makes life easier. Can I erase this one? So convex mirror is where it's like mirrored like this. Okay. So we still do the same thing, but convex mirrors, instead of focusing on one point, spread it out. So the first line we draw, as everybody see, because the focal point and the center curve are on the other side, since the mirror's curved this way. So we go straight over. And where do you think the next one's going to go?
So bad.
Focal.
Remember, we're reflecting off of here, so it can't go through the focal point. What do you think it does instead?
Freaks out.
The opposite direction.
Yeah, going up. So it looks like it's coming from the focal point. So like that. So on the focal point where it intersects, and it goes out like that. Does that make sense?
How did you figure that out?
What?
How did you decide that?
So we drew the one straight there, parallel to that, and then we lined up where that hit the mirror and the focal point, and drew a line out.
You just don't draw it through the focal point.
You just don't draw it through the focal point. We actually will in a second, but. Alright. Questions on how we gotta do those two? The handles are lifting up in the ceiling.
That's funny. That's cool. What? Can you see the mogas I went in?
Okay. Next one, we act like it's going through the focal point. It's gonna hit the mirror first, obviously. And how does that gonna reflect, do you think? Parallel. So it reflects back parallel like this. Okay. Do those two ever intersect? Behind behind the mirror, they look like they intersect. Never intersect on this side, but they will intersect, like where it appears like they're coming from, will intersect back here. We draw dotted lines. You don't have to draw dotted lines behind the mirror, I always just do. So, our image, the two dotted lines intersect right here. So that's where the image forms. So is that real or virtual? Upright or inverted? And smaller. And no matter how far away I pull this arrow, it's always going to do the same thing. It'll go toward the mirror and back. And so when you have a convex mirror, you can only form virtual images that are upright and smaller. Does that make sense? Because the light spreads the mirror spreads the light out instead of focusing it, you can never have a larger image or a real image. So no matter what you do, they're never going to intersect over here. And no matter what you do, they're never going to, like this parallel one is always going to be intersecting this one at a shorter point than the actual object. So kind of because geometry, you can never have a convex mirror magnifying something. So like one of the questions in your group quiz was, what kind of mirror would you use for magnification? Concave. Concave is the only kind of mirror that will magnify. A flat mirror is always the same size, and a convex mirror is always smaller. Does that make sense? You guys kind of understand that?
Yes, sir.
Alright, let's go through the little sheet that has kind of a summary of what we just did.
So is number 7 just the same
That's
thing?
okay.
Number 7 is just the same thing, so I'll have you guys do that on your own when you finish this, just for practice. Alright. Says this, I used to use one that was from like something called Toledo Physics, I don't use that anymore, sorry, I never changed it. Okay. Yeah. Number 1, when an image forms behind the mirror, we call it a blank image. Virtual. Number 2, when an image forms in front of the mirror, we call it a real image. Number 3, a mirror that focuses light onto a point is called a concave mirror. So the concave mirror focuses light onto a point, the convex mirror spreads it out. So a mirror that disperses light in all directions is a convex. So for all the following questions, the answer to the first blank will be real, virtual, or no image, and the second blank will be larger, smaller, the same size, or no image. Number 5, an object beyond the center of curvature of a concave mirror, a blank image is formed. So this was the first one we did when it was beyond the real. And the image is smaller than that of the object. When an object is at the center of curvature, a blank image is formed. Real. And the image formed is the same size. Right, number 7, when the object is between the center of curvature and the focal point of a concave mirror, a blank image is formed. Real. And the image is bigger. Number 8, when the object is at the focal point of a concave mirror, what happens? No image, no image. I know it doesn't make sense in those blanks, but no image is formed.
You sort of say no then?
You can say
No.
no image is formed and the image is no than the object.
No, yeah. I'll know what it means.
Okay. Number 9,
No.
when the object is between the focal point of the mirror, the focal point in the mirror of a concave mirror, a blank image is formed.
No.
Virtual. And the image is larger. So this is an example of that would be like if you hold a girl holds their makeup mirror, they hold it close to their face, their image appears. If they pull that mirror away so that their face is now beyond the center of curvature, it appears, or beyond the focal point, it appears blurry. So you can only see your face in one of those like magnifying mirrors if your face is inside the focal point. So closer to the mirror than the focal point of the mirror. Does that make sense? If you get further away, it'll get all blurry.
Does that depend on like the curvature of
It depends on the curvature of the concave mirror. Most of those are actually like slightly parabolic, but like when your face starts to get blurry is when you're at the focal point. All right. Number 10. Number 10, when an object is beyond the center of curvature of a convex mirror, virtual and
No.
smaller. Convex mirror can only be virtual and smaller. Number 11, when an object is between the center of curvature and the focal point of a convex mirror, virtual smaller. So if you see convex, it's virtual and smaller. So number 12, when an object is at the center of curvature of a convex mirror, virtual and smaller. So even if it's at the focal point of a convex mirror, it's virtual and smaller. 10, 11, and 12 are all virtual and smaller because it's all convex mirrors.
There's the bathroom.
Alright, so I want you guys to finish that last diagram. Do you guys have any questions about this before I shut off the video? It is.
So for this one,
I didn't say no sword fighting.
because
Alright, then we'll turn it into like
the reflection is lined up.
No lightsaber fighting either.
Can we